Now the general question is we want to determine the moment of force about 0.0 for each case. Determine. Yeah, of course. Sometimes I guess that's the drawback of having pictures ready. I just put it there and I keep going forward. Okay. So determine the moment of force about O, right? About 0.0. I'll just put O. It's technically in 3D space can be a vector, an axis. So I'm going to start from the first one, right? A. Go one by one. What is the moment for this case? Right? About 0.0 would be FD. Well, I have force 100 Newton. I have the magnitude of the force applied here, right? And the perpendicular distance from that point to 0.0, from the point that the force is applied to 0.0 that I'm trying to find the moment about, is 2 meters. So 100 times 2 is 200. And the unit for moment, can someone tell me what the unit should be?
Is there Newton meter?
Newton meter.
NM.
Exactly. NM. Because it's force multiplied by distance, which is pretty much length. So Newton meter. Now the direction, they already put the direction on these figures, but if you think about it, for this one, 4 fingers along the force, the palm of my hand towards the point that I'm trying to find the moment about. When I make a fist, right, my fingers show the direction of the moment. So it would be in this direction. It's a pretty ugly. I can do better. There you go. We usually put the moment, I guess it's easier. It's better if I just do it the way we do. Usually put the moment like this, the direction of the moment. So we know which direction you're talking about, because we are not writing in vector notation in 2D space. So B, let's look at this one. For the case at B, this one. What is the moment for this? Well, I do have the force. I know the magnitude of the force is 50. What is the perpendicular distance in this case?
Right. 0.75.
0.75, right? Because I want to find the moment of this force about 0.0. This is the perpendicular distance. This is D. There is no other way that you can find the perpendicular distance between that point and the force. So that would be 0.75. Right? I have this answer, hopefully. I think it's 37.5 Newton meter, and the direction this way, clockwise. Let's look at case C. So MO, moment about 0.0, would be force multiplied by the perpendicular distance. So force, I have 40 pounds in this case. It's not SI unit. So it's 40 pounds times. What is the distance, perpendicular distance, between that force and 0.0? I said something. It is 2 sine, well, two cosine, closer. So 2 cosine, I'm talking about point O. Point O is here, right? I want to find the perpendicular distance. So if you look at the direction, the action line for this force, yes, we got there slowly. 4 plus 2 cosine 30. So if this is the line of action for this force, the perpendicular distance would be this distance. This is D. And that D would be 4 plus 2 cosine 30. So I'm just going to put it here. 4 plus 2 cosine 30. If you do this math, you will get, I think, 229. And in this case, we have pound foot. All right. Not SI, it's US customer unit. The direction, again, 4 fingers along the line, palm of my hand towards the point that I'm finding the moment about, make a fist, right? It's clockwise. That would be the direction. Can do better. All right. Let's take a look at D. Still, it's a rod, some force is applied to it, right? Moment about point O is force multiplied by distance. Now, force I already know is 60 pounds. What is the distance in this case, or perpendicular distance? I'm finding the moment about point O. Keep that in mind. So you have to find the perpendicular distance between the force, or the force line of action, and point O. We're talking about case D. Three sine 45. 3 plus sine 45. So let's draw the line of action. This is the line of action for this force. This is the line the force is just sine 45. Yeah, pretty much. Right? So if this is the line and this is the point, the perpendicular distance is D here. Right? So that D is pretty much the same thing here. 1 sine 45. Or as you said, sine 45 kind of. So 1 sine 45. I don't know why I put 4 there. 1 sine 45 degrees. You do this multiplication, you'll get 42.4 pound foot. Now to find the direction, make it a little less crowded here. It's messy. To find the direction, this is still messy. Okay, this is better. So here is the 4 fingers along the force, pointing in the same direction. Palm of my hand towards the point that I'm finding a moment about. Make a fist. That shows the direction of the moment, which is the same direction they put there. This is the direction. Try it out. Make sure you actually get the sense of the direction. Now, the last case, E, well, let's find that. MO is F, what is such an F? FD. Force is 7 kilonewton. Let's just put it as Newton, 7,000 times. What is the perpendicular distance between the force, or the line of action for that force, and the point that I'm finding a moment about, which is O? 3. Right? Yeah, it is 3. So if this is the line of action here, or the force, this distance from here to here would be D. And D is pretty much just 4 minus 1. Think about it as 3 exactly. So that would be 21,000 Newton meter. And the direction of the force, palm of my hand this way, make a fist. This will go the direction.